Welcome back to the Learning Den. You know, it's the best place to get comfy and explore some seriously fascinating topics.
It is.
Today, we're diving deep into, this is one of the biggest mysteries of all time. What ended the reign of the dinosaurs?
Yeah.
So we've got a stack of research here, ready to dig into all the different theories. From a colossal asteroid impact
Right.
to fiery volcanic eruptions. Even the possibility of, like, a slow and steady climate change.
Yeah, you know, what makes this so much more than just ancient history is that it really helps us understand, like, the incredible forces that can completely reshape life on Earth.
Wow.
And guess what? Those forces are still at play today.
That's kind of scary.
Yeah.
Okay, well, let's start with the theory that's often seen as like the prime suspect in this prehistoric whodunit,
Okay.
the asteroid impact.
Right.
So picture this. 66 million years ago, at the end of the Cretaceous period, a massive asteroid, we're talking about the size of Mount Everest here,
Wow.
slams into Earth.
We're not talking about a little fender bender here. This was like a global catastrophe, and it left behind evidence that we can still see today.
That's amazing.
Yeah.
So let's talk about that evidence.
Okay.
Let's start with the Chicxulub crater in Mexico.
Right.
This isn't just any old crater. It's a massive scar, like 180 kilometers wide. And its age lines up perfectly with, when the dinosaurs went extinct.
Yeah, and the impact wouldn't have just like carved out this giant crater. We're talking shock waves that like rippled across the entire planet, tsunamis engulfing coastlines, wildfires raging across continents. It was a bad day to be a dinosaur.
Oh, definitely not a day for a picnic.
No.
Remember those scattered clues we mentioned earlier?
Yes.
One piece of evidence is this thin layer of clay, and it's found in rock layers all around the world. And it dates back to this exact time period.
Right.
And this layer, it's packed with iridium.
Iridium.
A rare element on Earth, but it's found in abundance in asteroids.
It's like a cosmic fingerprint pointing right at that massive impact.
That's incredible.
Yeah.
Okay, so we have a giant crater, a rare element fingerprint, and these unique geological formations. And they're all from the same time period as when the dinosaurs disappeared. That's pretty convincing evidence, right?
It is. It's one of the reasons why the asteroid impact hypothesis is so strong. But we have to consider all the angles.
Yeah.
And that brings us to another contender in our extinction event lineup.
Go ahead.
Volcanic eruptions.
All right, let's turn up the heat.
Yeah. Specifically, massive, long-lasting eruptions, like the ones that formed the Deccan Traps in India.
Okay, so we're talking about volcanic eruptions that lasted for thousands of years.
Thousands of years.
Spewing out an unbelievable amount of lava, like enough to bury an entire continent.
Imagine all the gases that were released by these eruptions, things like carbon dioxide and sulfur dioxide, flooding the atmosphere, causing global warming, acid rain, and making the oceans more acidic.
It sounds rough. So are we saying that volcanoes are the real dinosaur killers?
Well, it's a tempting theory, but there are a few snags. The timing of these eruptions, it doesn't quite line up with the sudden disappearance of the dinosaurs that we see in the fossil record. And plus, while the eruptions were undeniably massive, most of the evidence suggests that they just weren't powerful enough on their own to cause a global extinction event on the scale that we see at the end of the Cretaceous.
So maybe those volcanic eruptions were more like an opening act.
Ooh, that's a really interesting way to put it, yeah.
Setting the stage for the main event.
The eruptions likely caused significant environmental stress, which, could have made ecosystems more vulnerable to a sudden catastrophic event, like, say, an asteroid impact.
Ooh, okay. So we've got a possible accomplice.
Maybe.
Now, let's cool things down a bit and explore another possible culprit. Gradual climate change.
All right.
So could long-term shifts in temperature and sea level have just pushed the dinosaurs to their breaking point?
It's certainly possible. Imagine like a slow but steady change in climate over millions of years. Sea levels rising and falling, temperatures fluctuating. This kind of environmental pressure can definitely take its toll on ecosystems, and it can lead to changes in plant and animal life.
But wouldn't the dinosaurs have had time to adapt to these changes over such a long period?
You'd think so, right?
Yeah.
And that's precisely why this theory kind of struggles to fully explain the abrupt disappearance of so many species right at the KPG boundary.
Right.
Remember, the fossil record shows like a thriving, diverse ecosystem followed by a sudden dramatic drop in species, including the dinosaurs.
So gradual climate change, maybe it was a contributing factor,
It could have been.
making the dinosaurs more vulnerable, but it doesn't explain the suddenness of their extinction.
Exactly. It's more of a long game.
Right.
And the extinction we're talking about, it seems to have been more of a sudden knockout punch.
Okay, so we've got a leading suspect and a couple of possible accomplices. But what if it wasn't just one single cause?
Right.
What if it was a combination of all these factors and they just kind of worked together to deliver this final blow?
That's where things get really fascinating. We call this the perfect storm scenario.
Okay, I am intrigued.
All right.
Tell me more about this perfect storm.
So imagine this. Climate change is already putting stress on the ecosystem.
Yeah.
It's making them more fragile.
Uh-huh.
Then massive volcanic eruptions start spewing out gases, further disrupting the environment.
Okay.
And then, bam, the asteroid hits,
Oh.
delivering the knockout blow.
A triple whammy.
Yeah, it's a lot for any ecosystem to handle, even one as resilient as the one the dinosaurs lived in.
Exactly, yeah. And so this scenario, it's complex, but it could actually be the most accurate explanation, right?
It could be. It highlights how interconnected Earth's systems are and how multiple factors can kind of come together to trigger a truly catastrophic event.
So it's like a domino effect.
Yes.
Each factor amplifying the impact of the others. But even with this perfect storm scenario, the asteroid impact seems to be the main event.
Right. It does. It does. The evidence for the asteroid impact is incredibly strong, and it's still considered the most plausible primary cause of the dinosaur extinction. But these other theories, they offer valuable insights into the complex environmental tapestry that existed at the time.
Yeah.
And how different factors might have played a role in shaping this, this pivotal moment in Earth's history.
This is giving me a lot to think about.
It is a lot.
But before we get too overwhelmed, let's just take a moment to process all this incredible information. We've covered a lot of ground, from a giant space rock to fiery volcanoes and a slowly shifting climate. It's amazing to think how events that happened millions of years ago can still have such a profound impact on our understanding of the world today.
Yeah, I agree. It's a lot to unpack, but it really highlights how Earth's history isn't just about the past. It's woven into the fabric of our present and our future.
That's a great point. Okay, well, we'll be right back after a short break to delve deeper into the evidence surrounding the dinosaur extinction.
Okay.
So stick around. There's so much more to uncover.
There is. So, before the break, we were talking about the perfect storm scenario.
Right.
And it's a good reminder that we need to keep digging deeper into the evidence for each of these extinction theories.
Exactly.
We really want to get this right.
Right. We talked about the Chicxulub crater and how its size and age, it matches up with the dinosaur extinction.
Mm-hmm.
But what else makes scientists so sure that it was caused by an asteroid?
Well, the crater itself is a pretty massive clue, right?
Yeah.
It's the right size and shape for an impact, and it dates back to the exact time the dinosaurs disappeared.
Right.
But the evidence goes way beyond that.
Okay, so you mentioned that layer of iridium-rich clay that's found, all over the world. Can we dig into that a little more?
Absolutely. So imagine you're a geologist, and you're carefully excavating layer upon layer of rock. Each layer represents a different chapter in Earth's history, right?
Mm-hmm.
And right at the boundary between the Cretaceous and Paleogene periods, the moment that marks the end of the dinosaur era, you find this thin band of clay that's just loaded with iridium.
And I remember you saying that iridium is rare on Earth.
Very rare.
So what makes finding it in that layer so significant?
Exactly. Iridium is super rare on Earth's surface, but it's much more common in asteroids and other objects from space. So finding a sudden spike in iridium levels at the exact time the dinosaurs vanished, that's a huge red flag.
Wow.
It's like finding a tiny piece of the asteroid scattered across the entire planet.
Wow. So it's almost like the Earth itself kept a record of this cosmic event.
You got it. And remember those tektites and shocked quartz crystals we mentioned earlier?
Yeah.
They were found in that same layer, too.
Wow.
Tektites, those are those tiny glassy spheres. That form when rocks are vaporized by an impact and then they cool super fast in the atmosphere. Shocked quartz crystals, on the other hand, have unique microscopic features that only form under incredible pressure of, well, something like a massive asteroid impact.
Yeah.
Really big.
Like these geological markers are telling the story of that catastrophic event, even millions of years later.
Precisely. These clues, they're found globally, and they provide strong evidence of this massive impact event 66 million years ago.
Right.
But the evidence doesn't stop there.
Okay.
I mean, think about the immediate aftermath of an asteroid the size of Mount Everest.
Yeah.
Slamming into the Earth at tens of thousands of kilometers per hour.
Okay, yeah, I'm trying to wrap my head around that kind of impact.
Yeah.
It had to be devastating.
Devastating doesn't even begin to describe it.
Yeah.
I mean, the impact would have triggered unimaginable earthquakes, tsunamis that dwarfed anything we've ever seen, and wildfires that raged across continents.
I can only imagine the chaos.
It was total chaos.
So even with all that immediate destruction, how did the impact ultimately lead to a mass extinction?
Well, you see, the initial impact was just the beginning.
Okay.
Think about all the dust and debris that was blasted into the atmosphere.
Yeah.
Billions of tons of it blocking out the sun and plunging the planet into darkness.
Wow.
It would have been like a global nuclear winter.
That sounds terrifying. So without sunlight, I'm guessing plants would have really struggled to survive.
You got it. And without plants,
Yeah.
entire food chains would have collapsed.
Right.
And the drastic drop in temperature would made it nearly impossible for a lot of species to survive, even if they managed to make it through the initial impact.
So it wasn't just the impact itself, but this cascade of environmental consequences
It was everything.
that led to the extinction.
Exactly. The asteroid impact was like a trigger.
Right.
Setting off this chain reaction of disasters that ultimately reshaped life on Earth.
Oh, yeah.
It really shows how interconnected Earth's systems are.
Right.
And how a single event can have such profound and lasting consequences.
It's a humbling thought,
It is?
but also incredibly fascinating.
Very much so.
So, okay, the evidence for the asteroid impact is pretty compelling,
It is.
but we have to be thorough.
Yes, absolutely.
So let's revisit those other theories, starting with the Deccan Traps volcanism.
Right.
I mean, those eruptions, they were massive.
They were absolutely massive, and it's important to consider all the angles here.
Right.
The Deccan Traps eruptions, they released enormous amounts of volcanic gases over an incredibly long period of time. We're talking thousands of years.
Right, yeah.
And these gases, like carbon dioxide and sulfur dioxide, they would have had a significant impact on the global climate, causing warming, acid rain, and something called ocean acidification.
Okay, I'm familiar with acid rain, but what exactly is ocean acidification?
Well, as the ocean absorbs carbon dioxide from the atmosphere, it becomes more acidic. Yeah. And this can have a devastating impact on marine life.
Okay.
Especially creatures with shells made of calcium carbonate, like corals and many types of plankton. And these tiny creatures are the foundation of marine ecosystems. Yeah. So their loss would have had ripple effects throughout the entire food chain.
So even though we don't have a giant crater in India to point to, these volcanic eruptions, they were clearly a major environmental stressor.
Oh, absolutely.
But could they have caused the extinction on their own?
That's the big question scientists are still grappling with.
Yeah.
The timing of the eruptions is a bit of a puzzle.
Mm-hmm.
Some studies suggest that the most intense eruptions actually occurred after the asteroid impact.
Oh, wow.
Perhaps even triggered by the impact itself.
So it's possible the asteroid impact actually amplified the volcanic activity.
It's possible.
Making a bad situation even worse for the dinosaurs.
Potentially. Yeah, the impact could have generated massive shock waves that traveled through the Earth.
Right.
Destabilizing the crust and leading to, more intense volcanic activity.
Yeah.
Imagine it like shaking up a bottle of soda.
Okay.
The impact would release a lot of pent-up energy.
Right. That makes sense. So we have this potential link between the impact and the eruptions.
Yes.
What about the gradual climate change theory?
Right.
Does that still hold any weight in light of all this evidence?
Well, gradual climate change is definitely a factor we need to consider.
Yeah.
Earth's climate has always been in flux.
Uh-huh.
And we know that there were significant changes in temperature and sea level during the late Cretaceous period.
Okay.
These changes, they definitely would put pressure on dinosaur populations.
Right. But if If those changes were happening over millions of years, wouldn't the dinosaurs have had plenty of time to adapt?
Well, you'd think so, right? And that's one of the reasons why it's hard to pin the extinction solely on gradual climate change.
Right.
It doesn't explain the sudden, widespread disappearance of so many species right at that KPG boundary.
So gradual climate change might have set the stage,
It could have.
but it wasn't the main event.
Exactly. It provides important context,
Right.
but it doesn't fully solve the mystery.
All right, so we've got a compelling case for the asteroid impact,
Yeah.
a possible connection between the impact and the Deccan Traps eruptions,
Uh-huh.
and this long-term climate change trend that they could have made the dinosaurs, more vulnerable.
More fragile, yeah.
It's amazing to think how all these events, separated by millions of years, might be intertwined.
It really is. And it highlights just how complex Earth's history is.
This deep dive has really opened my eyes to the power of these planetary forces
It's incredible.
and how they've shaped life as we know it.
For sure.
I'm eager to keep exploring. But for now, let's take a pause
Okay.
to reflect on everything we've learned so far.
Yeah.
I mean, we've unearthed some incredible evidence, pieced together a complex puzzle,
You have.
and started to grasp the magnitude of this ancient extinction event.
It's been quite a journey, and we're not done yet.
We'll be right back to delve deeper into the aftermath of the dinosaur extinction
All right.
and explore what rose from the ashes of that ancient world.
Great sight.
So don't go anywhere. We've been on quite a journey today, exploring this ancient world of dinosaurs and massive asteroids and volcanic eruptions.
It's been fascinating.
It really has, but we can't just stop at the extinction, right?
Right.
What happened after the dust settled?
Yeah.
What rose from the ashes of that lost world?
Well, that's the really fascinating part. You see, extinction events, as devastating as they are, they also open up these incredible opportunities
Okay.
for new forms of life to kind of emerge and flourish.
Right.
It's almost like hitting the reset button on evolution.
Wow. So we're talking about like a post-apocalyptic world,
Yeah.
but for dinosaurs.
Pretty much.
So who are the ultimate survivors?
Yeah.
Who stepped into the spotlight after the dinosaurs, exited the stage?
Well, during the reign of the dinosaurs, mammals were these small, mostly nocturnal creatures
Right.
living in the shadows.
Okay.
But after the extinction event kind of cleared the playing field,
Yeah.
mammals had a chance to diversify and evolve in ways they never could before.
So the dinosaurs' loss was the mammals' gain.
In many ways, yes.
Wow.
Without, large predatory dinosaurs dominating the landscape,
Yeah.
mammals were free to explore these new ecological niches, evolve new adaptations, and ultimately take over as the dominant land animals.
It's almost poetic, this cycle of extinction and renewal.
It is.
But what evidence do we have that mammals actually benefited from the dinosaurs' disappearance?
Well, the fossil record tells a pretty compelling story.
Yep.
Before the impact, mammal fossils are relatively rare,
Uh-huh.
and they show limited diversity.
Okay.
But after that KPG boundary, the fossil record explodes with new mammal species.
Wow.
It's like someone flipped a switch on mammal evolution.
So we go from, a few small shrew-like creatures
Right.
to a whole menagerie of different mammals.
Exactly. We start seeing mammals evolving into a wide variety of shapes and sizes, from tiny burrowing creatures to massive herbivores like the woolly mammoth,
Right.
and eventually us. The extinction of the dinosaurs paved the way for the rise of primates,
Wow.
our ancient ancestors,
Yeah.
and ultimately led to the evolution of humankind.
It's incredible to think that our very existence is linked to this ancient extinction event.
I know, it's pretty wild.
It makes you wonder, if that asteroid had missed, would we even be here today?
It's one of those big, unanswerable questions that keep scientists and philosophers up at night. Would dinosaurs still rule the Earth? Would mammals have remained in the shadows?
Yeah.
Would humans have ever evolved? I mean, we can speculate, but we'll never know for sure.
It really highlights the role of chance in shaping the course of evolution, doesn't it?
Absolutely.
This one seemingly random event,
Mm-hmm.
an asteroid impact,
Yeah.
can completely change the trajectory of life on Earth.
It really underscores just how interconnected and delicate the web of life truly is.
As we wrap up this incredible deep dive into the dinosaur extinction, I'm struck by the power of Earth's history
Yeah,
to inform our understanding of the present and even the future.
I couldn't agree more.
It's a reminder that extinction events while often catastrophic, can also be these powerful catalysts for change,
Yes.
leading to new and diverse forms of life.
New possibilities.
And it highlights the importance of protecting the biodiversity we have today.
Absolutely.
After all, we don't want to be the next dinosaurs.
That's a great point. We have a responsibility to learn from the past and work to ensure a thriving future for all life on Earth.
Well, I think that's the perfect note to end on.
It is.
This has been an absolutely mind-blowing exploration of one of the most pivotal events in Earth's history.
It really has.
It's been a pleasure joining you on this deep dive. To all our listeners out there, thanks for joining us in the Learning Den. We'll see you next time for another fascinating journey into the world of knowledge and discovery.